Alright guys, today we're going to be doing problem 1.35, which basically asks us to verify corollary 1 in the textbook, which says that only the boundary line matters when you're using Stokes' theorem, not the surface used. So in the example, they integrate over the boundary line of this cube, which is open in the back here, and they get that to be equal to 4/3. So I'm just going to be verifying that adding up the integrals for each of the other surfaces of this cube is going to give us the same answer. The function it gives us is 2xz plus 3y squared y hat plus 4yz squared z hat. And then first you're going to have to start off by taking the curl here. So I took the gradient, crossed with the vector. And then when you go over here and work that out, you're going to get 4z squared minus 2x x hat minus 0y hat plus 2z z hat. And then you're going to be using the curl to integrate over all these other surfaces. So you go down here and you do the right and left sides first. I did dA equals dx dz y hat. So then v dot dA is going to be 0 because, as you can see, there's a 0 in the y hat term there. Then I went over to the left side and did dA is equivalent to minus dx dz y hat. Same thing, you're going to get v dot dA equals 0 because of that 0 in the y hat term. The next one I did was dA equals dx dy z hat. So then that v dot dA is going to be equal to something. It's equal to 2z dx dy hat. But because you're integrating off the top of the cube here, z is equal to 1. So when you go and do the surface integral, you're going to get integral from 0 to 1, 0 to 1, 2 dx dy, which basically just equals out to 2. Next, I did dA equals minus dx dy z hat. So the bottom part of the cube. Pretty similar to the last one, you're going to get v dot dA of minus 2z though, but then since you're on the bottom of the cube, z is equal to 0, and then it just all cancels out. And then the last one I did is the front surface of the cube here, the x hat. So you get dA equals dy dz x hat. V dot dA is going to be 4z squared minus 2x dy dz. And then on the front of the cube, x is equal to 1. So then that makes it 4z squared minus 2 in this surface integral here. Once you work that out, you're going to get to 4/3 minus 2, which goes out to negative 2/3. And then you're going to go sum all this up over here. You get 0 plus 0 plus 0, and then you get plus 2 minus 2/3. All that works out to 4/3, and then it checks out. So yeah.